Hello everyone and welcome to your partner in education, Agile Rank Mate. Today, in this particular episode of ANTHE, we'll be looking at some sample questions of the Aakash National Talent Hunt examination. We'll be looking at questions related to physics for grade 9. Let's start off with our first question. A train travels the first 15 kilometers at a uniform speed of 30 kilometers per hour. Next 10 kilometers at a uniform speed of 20 kilometers per hour, and the final 75 kilometers at a uniform speed of 50 kilometers per hour. The average speed for the entire journey of the train is A, 40 kilometers per hour, B, 50 kilometers per hour, 1, 40 kilometers per hour, 2, 50 kilometers per hour, 3, 40 meters per second, 4, 50 meters per second. So, how do we solve this question? Well, the question says, in the first 15 kilometers, the train traveled at a uniform speed of 30 kilometers per hour. So distance D1 is 15 kilometers, and the speed S1 is 30 kilometers per hour. The next 7 kilometers can be taken as D2, and the speed at which the train traveled, which is 20 kilometers per hour, can be taken as S2. 75 kilometers is D3, and its speed is S3. Now, we know the total distance, we can calculate the total distance to be 15 plus 10 plus 75. Now that is equal to 100 kilometers. But how do we calculate the time? Well, in order to calculate the time, let's consider T1 to be D1 over S1. So T1 is the time that the train took to travel the first 15 kilometers at a uniform speed of 30 kilometers per hour. D1 stands for the distance, which is 15, and S1 stands for the speed, which is 30. So therefore what we get is 1 over 2 hours. So basically 0.5 hours. T2, that is time taken for the train to travel the second stretch of 10 kilometers at a uniform speed of 20 kilometers per hour. D2 over S2, which in this case is 10 over 20, again, which would result to 1 by 2 hours. So the first half an hour was the first leg of the journey, the second half an hour was the second leg of the journey. Now for the third leg of the journey, the time taken for that, which is T3, would be equal to D3 over S3. So here D is 75 and here S is 50. So therefore what we get is 3 by 2 hours. So from all of this, we can find that the total time taken is 1 by 2 plus 1 by 2 plus 3 by 2, which is equal to 5 by 2 hours. Now, we need to find the average speed for the entire journey. The definition of average speed is total distance traveled over total time taken. Now that gives you the average speed of the journey. Doesn't have to be the speed at which the train moved. It could go faster than that and slower than the average speed. However, by calculating the total distance and the total time and dividing them, we would still get the average speed. So average speed for this particular scenario would be 100 kilometers over 5 by 2 hours. And that's the reason why I kept them as fractions instead of decimals. because if we kept it as decimals, then this would come out to be 2.5 hours. So 100 kilometers over 2.5 hours. So by using the fraction form, what we can do is we can take the denominator of 5 by 2 up to the numerator. So what we get is 100 times 2 over 5. So 5 goes into 120 times. So basically what we have is 20 times 2, which is 40. So 40 kilometers per hour turns out to be the right option. So option 1, 40 kilometers per hour, is the right option. Option 2 and option 4 are incorrect because the numerical value is different. It's showing 50 when in fact it's 40. And option 3 is incorrect because the unit of speed is different. 40 meters per second is way faster than 40 kilometers per hour. And since using our calculations, we found that the average speed is in kilometers per hour and it's 40 kilometers per hour. So therefore, option 1 is the right option instead of option 3. Now, let's look at another question. A football player kicks a 0.5 kilogram ball and imparts it a velocity of 10 meters per second. The contact between foot and ball is only for 1/50th of a second. What is the kicking force? Well, 0.5 kilograms is the mass of the ball. The velocity of the ball is 10 meters per second. Now, of course, when you're kicking a ball, in this particular scenario, we assume u equals to 0 because the football player kicks a stationary ball. And the final velocity v is given as 10 meters per second. The time the contact between foot and ball is only for 1/50th of a second. That means the difference in time is 1/50th of a second. You need to find the kicking force. Well, force is change in momentum over change in time. So over here, the mass of the ball stays the same throughout the motion. So m times delta v over delta t. Now delta v is v minus u, which in this case is 10 minus 0, which in this case is 10. So the mass is 0.5 and the velocity, the change in velocity is 10 meters per second over delta t, which is the time difference, which we know as 1/50. So 0.5 times 10 gives you 5. So 5 over 1/50. All you have to do is to use the same idea here. So 50 goes to the numerator. 5 into 50 over 1, which means 5 into 50. So 5 times 50 is, of course, 250. And the unit here would be kilogram meters per second, because we're dealing with mass, velocity, and time. So therefore, what we're getting is, of course, option 1, 250 Newton, because 1 Newton is the same as 1 kilogram meters per second squared. The other options are incorrect because they're not numerically the right answer. The right numerical answer is 250 and its correct unit is kilogram meters per second squared, which of course also means Newton. Now, of course, if you are wondering as to how the fractions were calculated here, so basically if you divide two fractions, it's the same thing as multiplying with the second fraction's inverse. So 1/5 divided by 2/5 is the same thing as 1/5 into 5/2. So that's the idea that we're using here for the first two questions. In order to make our calculations simpler, we've put them into fraction form, and then in the cases where this is applicable, we just used its inverse in order to solve the question. Now, let's move on to the next question. At what height from the Earth, acceleration due to gravity will be half the value of g on the Earth? You are told to consider the radius of the Earth as 6.4 into 10 raised to 6 meters per second. So, how do we solve this question? Well, acceleration due to gravity at a particular height, which we will write as gh, is equal to g times r over r plus h, the whole squared. So g here stands for acceleration due to gravity at the surface of the Earth. And in the question, acceleration due to gravity is given as half the value of g on the surface. So gh over g is equal to 1 over 2. Now remember this formula for the acceleration due to gravity at a height, we can convert it to gh over g as equal to r divided by r plus h, the whole square. So basically this right hand side here and this right hand side are equal because they share the same left hand side. So in effect what we get is r divided by r plus h, the whole squared, gives you 1 by 2. Now of course if we take square root on both sides, what we get is r over r plus h as equal to 1 over root 2. Now in order to make our calculations simpler, what we're going to do is we're going to take the inverse on both sides. So basically, if r by r plus h is equal to 1 over root 2, then r plus h over r will be equal to root 2 over 1, which is equal to root 2. Now from here, we're going to split the left-hand side into r by r plus h by r. Equals to root 2. So therefore 1 plus h by r, because the numerator and denominator are the same, so that will be equal to 1. So 1 plus h by r is equal to root 2. So therefore h over r is equal to root 2 minus 1, which means the value of the height from the earth at which the object has half the value of object will experience half the value of acceleration due to gravity. So therefore that particular height h is equal to root 2 minus 1 times r. So all we have to do is we have to substitute the values here. So root 2 is approximately equal to 1.414, and r is given as 6.4 into 10 to the power 6. So 1.414 minus 1 is of course 0.414 times 6.4 into 10 to the power 6. So since we already have 10 to the power 6 as part of the answer, we're going to use the multiples of 10 inside this in order to remove the decimal points. So 0.414 can become 414. We'll just have to take 10 cubed out of it and multiply it here. 6.4 can become 64 if you take 10 out of 10 to the power 6. So what we have is 414 times 64 times 10 squared, which in effect is 100. So all you have to do is multiply 414 with 64. 16, 5, 16, 24, 8, 24. So what we get is 6, 9, 4, 6, 2. So what we're getting is 2649600, and the unit of distance here is meters. So when you divide that by 1000, so the height now will be equal to 2649.6 kilometers. So that is the exact height at which acceleration due to gravity will be half the value of g. So therefore the closest answer to that particular value is indeed option 3, 2650 kilometers. So by the way, the unit here is always kilometers because the option gives us the unit of distance as kilometers. So 2649.6, if the decimal value is over 5, we can round it off to the next largest number. So therefore 2,650 kilometers is the right option. The other options are incorrect. So basically, it's important to note that there are two formulas for calculating the acceleration due to gravity at a height h. You can also use 1 minus 2h by r times the acceleration due to gravity on the surface, but that particular formula is only for values of h that are very small compared to r. Here we didn't know what the value of h was, so therefore the original formula that goes gh equals g times r by r plus h the whole squared, that is the formula that we need to be using. So using that, we just had to play around with the quantities in order to make our calculations as simple as possible. And once we did that, we got the answer as 2,650 kilometers. So option 3 is the right option. Now, next question. An object of mass 1 kilogram has a potential energy of 1 joule relative to the ground when it is at a height of 0.102 meters, 0.32 meters, 0.15 meters, 0.98 meters. So we're dealing with potential energy. So potential energy is calculated as mg times h. So potential energy is equal to mgh. Then the height, which is what we need to calculate here, would be potential energy over mg. So potential energy is given as 1 joules. The mass of the object is 1 kilogram, and we're going to take g as equal to 9.8 meters per second. So basically it becomes 1 by 9.8. Let's remove the decimal by multiplying 10 to both sides, so we get 10 over 98. When we divide 10 over 98, of course, the answer is in decimals, so we'll add a 0 to 10 to make it 100. So 1 times 98 is 98. Remainder is 2. Now again, even if we add a 0, it wouldn't work, so we have to make it 0.10. So obviously by then you would know that the answer is option 1, 0.102, because numerically the other options would be disproved by then. Because now we have 0.32 as option 2, 0.98 as option 4, and 0.15 as option 3. However, just for the sake of continuity, let's add a 0 here to make it 200. 98 times 2 is 196. So we have 4. So the quotient, if you look at it, is approximately equal to 0.102. So 0.102 meters is the correct option for this question. So option 1 is the correct option. Now let's look at the final question for today. The speed of a wave in a certain medium is 960 meters per second. If 3,600 waves pass over a certain point of the medium in 1 minute, you need to find the wavelength of the wave. So 960 meters per second is wave speed. Wavelength is represented as lambda. So the relation, however, before we delve into the relation between v and lambda, let's look at the second statement. If 3,600 waves pass over a certain point of the medium in 1 minute. So what it says is you have 3,600 waves in 1 minute. However, we also know that 1 minute is equal to 60 seconds. So if we were to calculate the number of waves in 1 second, we just have to divide 3,600 over 60. That would, of course, give you 60. So therefore, in 1 second, you have 60 waves. That means we have, in effect, found out the frequency of that particular wave. So frequency, represented as nu, is equal to 60 hertz. So, now that we've found out the frequency from the particular statement, let's find out the wavelength. Wavelength lambda is related to speed of the wave and its frequency by the following. So lambda is equal to v over nu. It's kind of like distance over time. We just have to make sure that frequency is 1 by time. So therefore, if in motion distance is speed into time, then in the case of wavelength, it would be wave speed over the frequency. So we'll just have to substitute the values. So the wave speed is 960. The frequency is, of course, 60 hertz. So 6's get cancelled. We just have to divide 96 over 6. That would be, of course, equal to 16. So lambda, or the wavelength of the wave in question, is option 4, 16 meters. So all you have to do is to remember lambda equals wave speed over the frequency. So that's how we find the wavelength. Now that concludes this particular episode of Answer ANTHE. We hope you found this episode interesting and informative. For more of our useful and interesting content, don't forget to subscribe to Agile Rank Mate, your partner in education. If you want to learn the latest updates from our channel, then please don't forget to hit the bell icon present below the video. So until the next episode, take care, stay alert, bye-bye for now.